Happy Wednesday. All right, so just want to briefly go over what we did last week. Last week we talked about matrices and inverses, determinants, multiplying them, and adding them, and subtracting them, and all that fun stuff. We're going to need these two concepts, finding the inverse of a matrix and multiplying two matrices together today. And so we're going to need to do that so let's get a little warm-up going in with these. So remember, when we're finding an inverse matrix, okay, the first thing that we need to do is we need to find the determinant of that matrix. Okay? So the determinant of this matrix, remember, is the Chris's. So I multiply those two together, 10 times negative 3, and then minus the crosses, 5 times negative 8. And then we just simply do that math. So 10 times negative 3 is negative 30. 5 times negative 8 is negative 40. Negative 30 minus a negative 40 is 10. So the determinant is 10 for this particular matrix. Then, to find the actual inverse of that matrix, we say that, sorry, I'm just jumping around, the inverse is going to be 1 over the value of that determinant, so it's 1 over 10, times the 2 by 2 matrix, and I switch positions with those two, and I negate the other two. So that right there, ladies and gentlemen, is how you find an inverse matrix. Okay? Remember, we switch in that blue circle up here. So we switch spots there, and we negate in the green circle. In the green circle, we switch the signs in both of those. Okay? So that's inverse. Check back last week's notes if you're still having questions with that, or pop into the Google Meet from 10 to noon at Lynn's office. Multiplying two matrices. First, we have to see if we can do it. This is a 2 by 2 matrix. This is a 2 by 2 matrix. We can do that because these two middle numbers are the same. The outer two numbers give you the result. So the result here is going to be a 2 by 2 matrix. So to do that 2 by 2 matrix, I take the first row of the first matrix and I multiply it by the first column of the second matrix. So that would be 8 times 5 plus negative 2 times negative 4. Then I take the first row times the second column. That would be 8 times 3 plus negative 2 times negative 1. Then I take the second row times the first column, negative 6 times 5, and 0 times negative 4. And then lastly, I take the second row and the second column, negative 6 times 3 plus 0 times negative 1. Then I just do all of that math. So this is going to then be 40 plus 8, 24 plus 2, negative 30 plus 0, negative 18 plus 0. So my end result, the 2 by 2 matrix, is going to be 48, 26, negative 30, negative 18. Okay. Again, we'll need those two concepts for what we're doing. So let's
let's talk a little bit about this week and next week. So today we're going to learn how to solve systems with matrices. I'm going to introduce you to it. Tomorrow we're going to enhance how it's done and hopefully get, okay, look at that. You're all late to homeroom. Tomorrow we're going to enhance how it's done, go through some more examples of that. And then Friday we're going to do one example at the start of class, solving by matrices, and then you're going to have a formative assessment on Friday. No test. Notice how the test has been moved to next week, Wednesday. That gives us Monday to review. Tuesday is, and then, just looking at the calendar. Yeah, so that puts it on the 1st of March. Okay? All right, here we go. Let's do this. So, give you a couple of seconds here to write down this problem. 5x minus 2y equals negative 10. 2x minus 4y equals 12. Again, you can always pause the video and go back, scroll back 10 seconds or so if I'm going too fast for you. Okay? So the first thing that you need to do is you need to make sure that you got it lined up like this. X's, then y's, then the equal sign, then the numbers. It has to be lined up just like that. Okay? So then, once that's done, we are going to convert that system to a matrix equation. Real simple to do. The first matrix is just the coefficient matrix. 5, negative 2, 2, and negative 4. That's why it's so important to have your equations lined up, x, y equals number. So that's the first one, is literally just the coefficients of the variables written in that exact same order. Then the next matrix is going to be your variable matrix, x and y. Now, if you'll notice, this is a 2 by 2 matrix. This is a 2 by 1 matrix. When I multiply those two together, I get a 2 by 1 matrix. Well, that 2 by 1 matrix that I'm going to get is the numbers. And so it's legal. So your first matrix is the coefficients. Next matrix is the variables. And that's going to equal the numbers. Okay? So that's step number 1. We have to convert our regular old system of equations into a matrix equation. Step 2 then says, now we're going to find the inverse of the coefficient matrix. So I'm going to find the inverse of this matrix right there. Okay? Well, again, we just did that in the warm-up. We did it all last week. So the first thing I need to do is I need to find the determinant of that matrix. Well, that's going to be 5 times negative 4 minus 2 times negative 2. 5 times negative 4 is negative 20. 2 times negative 2 is negative 4. So that's going to give me negative 16. So the inverse, we'll just call it matrix A for now. The inverse would be 1 over negative 16 times negative 4, positive 2, negative 2, and 5. Okay. Now it's going to be easy for you to see your work flowing. I've got to scroll down, and so it'll take me just a little bit to write down some stuff here, but that's okay, because it'll take you some time to write down the stuff. So now what we're going to do is we're going to multiply that inverse matrix by the number matrix. And we're going to do it in a specific order. Okay? So that order is going to look like, let me scroll back up here for a minute. Okay? So if I multiply by the inverse over here, these two matrices will then cancel each other out, because when you multiply by an inverse, it cancels it out to 1. So those two are going to be gone. But then I got to multiply by the inverse on the right side. Well, because order matters in matrix multiplication, I have to multiply by the inverse on the left side, because I multiplied on the left side over here. Okay? So what that looks like then is it's going to look like we're going to have our variable matrix is the only thing that's going to be left on the right, or excuse me, on the left side of the equation. My inverse matrix is going to look like this, and then that was -4 and 2, -2 and 5. And then I'm going to have my numbers matrix, which was -10 and 12. Now, that's a legally doable 2 by 2, 2 by 1. Can legally multiply those two matrices together, and I get a 2 by 1 coming out. So let's do it. We're going to leave this -1/16 out in front, and then we're going to have a 2 by 1 matrix inside. So I'm going to take the top row, -4 times -10, plus 2 times 12 times the 1 column, so top row times the column. And then I'm going to have bottom row. Times the column. And so we're going to have that. Let's do that. So we're still going to have 1 over -16 out in front. Oh, what's that going to be? 40 plus 24 and 20 plus 60. $64 and 80. Sorry, I got a sneeze building. Don't worry, I paused the video in order to do that sneeze. Okay? Now, I've told you in the past you don't have to multiply this number in, but in terms of solving, we have to distribute this number into both parts of that. And the nice thing is it should give us a nice, easy number. Well, in this case, it does. It gives us -4 and -5. So that, if you recall, is what our variable matrix is equal to. So in our last step, then, we are going to put the resulting matrix back into point form, and we're going to check our answer. Here's our original equation. So our suspected answer then in point form would be -4, -5. 5 5 times negative 4 is negative 20. Negative 2 times negative 5 is positive 10. Negative 20 plus 10 is negative 10. 2 times negative 4 is negative 8. Negative 4 times negative 5 is positive 20. Negative 8 plus 20 is 12. Checks out. There is our answer. Now, you're probably saying to yourself, Linz, we're 15 minutes into this video. Why do we have to learn this stuff? Well, for a 2x2 matrix, it is very easy to do. But when you get to bigger equations, 3x3s, 4x4s, etc., it is the preferred method because it is so fast. It's just finding an inverse, multiplying that by the answers from the original problem, and that's it. That's done. Okay? Let's try one more. We'll solve this one using matrices, and then we'll be done for the day. So first check, make sure it's an x, y equals number form for both equations. Yep, that's done. Second one then is create our matrix equation. 3, negative 4, 2, negative 3. X and y. 5 and 3. Okay. Then our variable matrix is going to equal the inverse. Well, so the determinant is going to be 3 times negative 3 minus 2 times negative 4. That's going to be negative 9 plus 8, which is negative 1. So my inverse is going to be 1 over negative 1, negative 3, positive 4, negative 2, positive 3, times, wrong color, times 5 and 3. It's going to give me a 2x1 matrix. The reason I know it's because it's got to equal the left side of the equation, which is a 2x1 matrix. So we're going to have 1 over negative 1 times negative 3 times 5, 4 times 3, first row, first column, negative 2 times 5, plus 3 times 3, second row, first column. That's going to be negative 15 plus 12, negative 10 plus 9. Scroll down. Oops. Okay. Negative 15 plus 12 is negative 3. Negative 10 plus 9 is negative 1. Multiply the negative 1 in, gives me 3 and 1. So my suspected answer then is going to be the point 3, comma 1. 3 times 3 is 9. 4 times 1 is 4. 9 minus 4 is 5. Checks out. 2 times 3 is 6. 3 times 1 is 3. 6 minus 3 is 3. Checks out. Boom. Done. Okay. If you need me, I will be on Google Meet starting at 10 o'clock from 10 to noon. The code to the Google Meet code. Lynn's office is my Google Meet code for today and tomorrow if you have any questions from 10 to noon both days. Happy virtual day.